Okay, before I carry on, I just need to give you this house. I don't want to forget. Right, I want you to paste these acceptable reasons for geometry in your main fraction. Okay? All the reasons that you give when you're writing a test and so on, please make sure you use the reasons that are here. I'm going to guide you as we move forward. Right? You paste this, you need this until you write matric. Okay. So paste it in your network book and you need to memorize the accessible reasons and you know what will be done. Sometimes I think you listen. Well, I didn't see you last week for a number of things. How intelligent put it in on the network where you can easily say, not in a separate file. Okay, both the file you can put it somewhere, or maybe you can put it in a shelf at home and so on. Now, the network, if you put your acceptable reasons in there under geometry, you can always refer. Okay. All right. Uh, so far, before I start going over this question, so far we are okay. There are many categories. So we have got lines. Now, under lines, okay, you did that already. That's grade 8, grade 9, and part of grade 10. Triangle, that's also grade 8, grade 9, part of grade 10. Okay, some of the stuff is grade 12 under triangles, but the bulk is grade 8 up to grade 10. Then circles, that's where we are. So far, can you go to circles please under the reason? Because I need to ask you to write some things there. Right? We have done, if you go to the third reason, that is the line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. The acceptable reason, line from center to midpoint of chord, that's theorem 1 converse. You can write that. That's theorem 1 converse. Are you following? Yeah, you need to write it down so you don't get confused. Okay? Under circles, the third theorem there and its reason, that is line from center to midpoint of chord, that's converse of theorem 1. Then the fourth one, the line drawn from the center of the circle perpendicular to the chord bisects the chord, that's theorem 1, the original theorem. That is the fourth theorem. Then the fifth one, go to circles. Okay? Number 3, under circles, the line drawn from the center to the midpoint of the chord. That's the converse of theorem 1. Then the one below it, that's the original theorem 1. That is the line drawn from the center of the circle perpendicular to the chord bisects the chord. That's the original theorem 1. Then theorem 1b, the perpendicular bisector of a chord passes through the center. That's the one below theorem 1. Are you following? Please do me a favor. You need to make sure you indicate and you are aware of this. Okay? Then we did theorem 2, the one below the theorem 1b.
You say the perpendicular of the line.
Theorem 1b. Right? Then the angle subtended by an arc at the center of the circle is double the size of the angle subtended by the same arc at the circle. That is, angle at center is 2 times angle at the circumference. That's theorem 2. You follow me? Then below, the one below it, the angle subtended by the diameter at the circumference of the circle is 90 degrees. That's theorem 3. Okay? And then the one below it, if the angle subtended by a chord at the circumference of the circle is 90 degrees, then the chord is the diameter. That's the converse of theorem 3. Okay? Okay, so that's where we are now. So, whenever I do a theorem, I'm going to refer you to the acceptable reason. You need to memorize the shortcut form of the reason. The shortcut form of the reason. Not only for the circles, but for everything you have done so far. This is what is acceptable from the department perspective. So I need to synchronize because some of your teachers they taught it differently in terms of what's there. So that should stop from now on. Give reasons based on what's on that document. Okay, let's come to the homework. All right. So here we have we are given a circle and we are given some dimensions, right? I just need to add some information on the diagram. All right. So what I'm gonna do is I'm just gonna label some of the stuff that's there. AB is 14 centimeters. So let me calculate. So this is 14 centimeters. Okay, and MP is 3 centimeters and OM is equal to X. All right, now we are supposed to determine the length of the radius. Okay, now I want you to be aware that on this diagram here, OP is a radius. Okay, also OA is a radius and OB is a radius. Okay, so first thing I'm going to write and say OA is equal to OB. They are both equal to OP. And they are going to be equal to X plus 3. And that's the reason of the radii. Okay? So your OA is equal to your OB. They are both equal to OP. Alright? And they are going to be equal to X plus 3. Alright? Then if I want to calculate the radius, either I can calculate the length of OA or the length of OP, which means I might need to know the length of AM or MB. So I'm going to determine the length of AM or MB. So what I'm going to do, okay, I'm going to choose AM, so I'll say AM is equal to half of AB, right? The reason that I have to give here, because we are given the 90-degree angle here. We have the 90-degree angle. It's drawn on the diagram, or it's indicated on the diagram. Then that's the original theorem 1. Line from center, perpendicular to the chord, bisects the chord. So the shortcut for that reason is line from center, perpendicular to chord. Okay? Line from center, perpendicular to chord. Like that. Okay? So our AM is going to be equal to half times AB. Now AB is equal to 14 centimeters, so that will be 7 centimeters. Okay? You following that? Do you have any question? Right. So we now know the length of AM. We know the length of OP is X plus 3, right? So what I'm going to do is I'm going to identify a right angle triangle that I'm going to use to determine the length of OA. Remember, OA is equal to X plus what? 3 plus 3. Don't forget that. This length here is equal to X plus 3. It's equal to X plus 3.
It doesn't matter if you use OA or OB, it's still going to be.
Yeah, it's still the same thing. Also, furthermore, OB is also equal to X plus 3. The reason is because all radii of any circle are the same. So it is your choice. No one should tell you whether you calculate OA only or OB only. No. Okay. Then once we get to this point now, I'm going to identify a triangle that I'm going to apply the theorem of Pythagoras. The triangle that I'm going to use is triangle AOM, because I know the length of AO in terms of x, I know the length of OM is equal to x, I know the length of AM, okay, it's equal to 7. So what I'm going to do, let me move on to the next page. I think I can squeeze it on top. Let me try to squeeze it on top. So I'm going to say, in triangle AOM, if I use the theorem of Pythagoras, that will be AO squared is equal to OM squared plus AM squared. That's Pythagoras. Okay? Now, AO is equal to x plus 3 squared, and OM is equal to x, so that becomes x squared, and AM is equal to 7 squared. Okay, now your knowledge of algebra is required here. And you can see that I have to form a quadratic equation, right? That's one of the reasons why you did quadratic equations first, because you need their application in geometry as well. Okay, so this becomes x plus 3 times x plus 3 equal to x squared plus 49. Okay, so that will give me x squared plus, allow me to write 6x here, plus 9 equal to x squared plus 49. Now, I'm sure you can see that this x squared and that x squared are going to cancel out. Because if I take either of the two to the other side, they will cancel out. So eventually, I'm going to end up having 6x is equal to, if I take the 9 to the other side, I'll get 6x equal to 40. Okay? Then we divide both sides by 6. So we get x equal to 40 over 6. Okay? I can simplify that. Okay? I can see this is not, remember that x equal to 40 over 6 is not the radius. Okay? It's not the radius. The radius is x plus 3. Okay? The radius is x plus 3. So, after getting it, just allow me to carry on down here. So, I'll say the radius will be equal to x plus 3, which in this case becomes 40 over 6 plus 3. Right? My suggestion, because of the nature of the sum there, we're going to get a common fraction, convert it to a decimal. So what is 40 over 6 plus 3 is a decimal, 2 decimal places. What? You get 9.67 centimeters. Okay, so we can leave it as a decimal. If you want, you can leave it as a common fraction as well. Right?
So,
Yes.
for the radius, okay, look at the x plus 3. What if the 3 was negative?
No, we don't have negative lengths when you are dealing with questions like this. There are no negative answers. Okay? If we are dealing with lengths, lengths are never negative. Okay? Length, it could be possible that you can also have x minus 3 as long as the x is greater than the 3. But generally, you need to be aware that when you are doing calculations in geometry, no negative answers. Okay? Any question?
So what if they talk about it in terms of how the 48 is?
Okay.
It doesn't matter.
Okay. I've already answered you. You can leave your answer as a common fraction or leave it as a decimal. It's your choice.
Choice?
So, can you show us where you get the 7 marks in this question?
Okay. Well, if I was the examiner, I would give a mark for this. Okay, let me use a different color that you can see. So I would give a mark here, and I'll give a mark for that reason and for the value of what? Of AM. Right? So I'll give a mark for the reason and for the statement and the reason. Now, I may also give a mark for that statement. Okay? it is my choice. It's 4 marks. Then here, theorem of Pythagoras, right? Obviously the answer, I could give a mark for finding the value of x.
So,
Okay? Yeah.
for the answer, would it be wrong if we found the LCE?
Okay, I think this discussion is, in my opinion, is very necessary. It's unnecessary. You can leave the answer. Okay, I'm not supposed to teach how to deal with fractions. That's not the objective of my lesson. When you get to this point, you are not supposed to have struggled with simplifying fractions. No. So I'm not going to talk about simplifying fractions. Okay? Use your calculator. Use your calculator. If you can't do it mentally, you use your calculator. Right. Let's not have discussion about basics of maths like fractions and all this stuff. Right? When you are doing geometry, the foundation is that you have done all the previous grades and all the concepts in those grades. So you are expected to know how to deal with fractions and equations. Okay, let me carry on to the next one. All right. The next question, the most important thing is that we are told that M is the midpoint of AB. And we also have the length of AB is 20. So that length there is 20. And OM is equal to X. And then M is the midpoint, obviously. Then we have got this ratio. This ratio is very important. Okay? PM over OM is equal to 5 over 2. That's very, very important. So they're saying PM over OM is equal to 5 over 2. But we are given OM as X. Okay? We are given OM as X. Okay. So what I'm going to do is, let's do the first one, 7.1. So 7.1, 7.1, write down the length of MB. Right? You don't have to give a reason because it's only 1 mark. So you just write the what? The answer. MB is half of 20, so that will be 10 units. So we can just write here, MB is equal to 10 units. You don't have to give a reason, but what will be the reason?
Line from center to midpoint.
Yeah, thank you. It will be line from center to midpoint of chord. That's the converse of theorem 1, because the bisection of the chord is indicated there. So it's the converse of theorem 1. All right? Then 7.2, give a reason why OM is perpendicular to AB. Why is OM perpendicular to MB?
Line from center.
I would suggest that you give the converse as the reason. So you can write because of line from center to midpoint of chord.
So what did you just say converse mean?
We don't write that way. Do you see that on that page? Huh? Yeah. So when you write a test, if you write converse theorem what, it's not me who taught you that. It's not in the examination guidelines. Okay? Then 7.3, show that OP is equal to 3x over 2. Right? Show that OP is equal to 3x over 2. Now here, your knowledge of ratios is required. Okay? You did ratios grade 8 and grade 9. So your knowledge of ratios is required for you to be able to show that OP is equal to 3x over 2. Now, I want you to be aware that to do this question 7.3, you need that information. PM is equal to PM over ON is equal to 5 over 2. Right. Now, I don't want to make the question complicated. I could introduce another variable like Y or K, but I don't want to do that. So I want you to be aware that our PM, okay, our PM is more like, based on this ratio here, it's 2.5 times bigger than OM. Okay? That's what that ratio is. So, if OM is equal to X, okay? If OM is equal to X, what will be the length of PM in terms of X? That's the question. Okay? So, to be able to calculate that, let me do it here, 7.3. Right? Now, you don't have to give like reasons there, but it's based on that ratio. So, what you do is, if you want to calculate PM, right? PM is going to be equal to 5 over 2 X, like that. Okay? Because OM, PM over OM, if I want, I can just start from there. Let me just start from there and then I'll. Okay, this is quite interesting, right? PM over OM is equal to 5 over 2. But what is OM? It's what? X. So this means PM over X is equal to 5 over 2. Therefore, PM is equal to 5 over 2x.
Also, cancel the X times by.
So, yeah. So, I just replaced the OM by X. And then made PM the subject. Following? No, that's not the answer. We need to show that OP is equal to 3x over 2. Now, since I now know the length of PM in terms of x, and I know OM is x, OP is from the center to P. So, I can say OP is equal to PM minus OM. You agree with me there? Huh? So this becomes, let me use a different color, that becomes 5 over 2x minus x, and the final answer that you get there is going to be 3 over 2x. So I have shown here how you can get OP as 3 over 2x.
So you don't use the 3x over 2 at all?
No, the question is show that you are not supposed to use what you are given to show. You are supposed to figure out a way of getting to OP of 3 over 2x. So that's what I've done. Alright?
How is power to X minus X?
You say
Where is your calculator?
So 5 minus 1 is 4.
What's the denominator here? What? What's the LCD? I'm asking him, what's the LCD? It's 2. If you multiply the x by 2, the 1 by 2, what is 5x minus 2x? It's 3x. Over the denominator, which is the 2. I'm not even supposed to talk about that.
Oh, yeah.
I'm not supposed to talk about that. Alright. So let's move on to 7.4. Calculate the value of x. Calculate the value of x. Now, to calculate the value of x, I hope that you can all see, okay? I hope you can all see that OP is a radius, so it's equal to OB. They are radii. Okay? So what I'm going to do is I'm going to move on to the next page. Okay? And then I'll carry on the next page. So 7.4, I'm going to say in triangle OMB, okay? I already know what MB is. I am given that OM is x, and I can determine the length of OB in terms of x. OB is equal to what? OP, yes.
So is naming the triangle very important?
Yes. It mainly helps the person who will be marking in terms of identifying how you are approaching the
So the way you say is that OMB, you say the OM, something like that.
Okay. Okay, all right, I get what you mean. No, you can name it as BOM, it's okay. Or you can name it as MBO, it's up to you. Okay, but my suggestion is always identify the what? The triangle. Okay. Whichever way you name it, It's not a major issue, yes?
So before you actually start the settlement, are you not supposed to say OD is equal to what's it, PM, and then they're equal to the X.
Okay, before I start 7.4, I'm going to start by saying OP is equal to OB because they are ready, I have to say. That's how I'm going to start with this. The reason why I have to do that because I'm not given or I didn't calculate straight away the length of OB. But the good thing is I know that the length of OP is equivalent to OB because they are ready, I have to say. So that's where I'm going to start. All right? So 7.4. So I'm going to start by saying, okay, just bear with me. Let me bring the diagram here. The chances of that are close to zero. All right, 7.4. So I was saying the length of OB is equal to OP. Fortunately, we know that this is 10 units. All right. So the first thing that I'm going to write is to say OP is equal to OB. They are both equal to 3 over 2x. And then my reason is radii. Okay. Then I'll say in triangle OMB, if I use the theorem of Pythagoras, my OB is going to be the hypotenuse. So I'm going to have, let me write it fully. So I'll say OB squared is equal to OM squared plus MB squared. That's Pythagoras. Okay? So my OB is going to be equal to 3 over 2x all squared, and OM is equal to x squared plus MB is equal to 10 units. So this will give me 9 over 4x squared is equal to x squared plus 100. Okay? The following. Then we want to solve for x. So we take this x to the left. We get 9 over 4x squared minus x squared is equal to 100. Now, the LCD here is going to be a 4. Okay? So we end up having 9x squared minus 4x squared. So you end up getting 5 over 4x squared is equal to 100. Then the denominator there is 1, you cross multiply. Okay? You cross multiply, you get 5x squared equal to 400. Then you divide both sides by 5. So you get x squared equal to, well, if I divide both sides, I'll get 80 here, like that. Okay? Are you following? Huh? Then my x is going to be plus or minus the square root of 80. What's the square root of 80? Okay, 80, I can write it as
4 squared 5.
going to be 4 square root of 5. Right, so because we did cells, so you get x equal to 4 times square root of 5. That's a plus or minus. But because length is always positive, therefore means that our x is going to be equal to 4 square root of 5. Four square root of 5. It's what? I think, let's see. I think there are units there. So 4 square root of 5 units. If you want, you can convert it to a decimal. What is 4 times square root of 5 to 2 decimal places? 8.14. 8.94 units. Right? And then you're done.
So is it x 14?
No, it's plus or minus. This is plus and the minus. Okay, let me use a different color but you can see it. So that's a plus and a minus. Okay. Any question?
So how do you manage the